Well, welcome to Turning Dollars with Microsoft Excel. There's a lot of talk about big data, but big data is basically being used to try and figure out how you can sell more selective stuff to somebody. But I have found that there are huge profits available from small data, and almost every company collects data about mistakes and errors and defects and things that go on in the organization, but most of them don't know how to analyze that data to find what I call the hidden low-hanging fruit, right? Everybody talks about low-hanging fruit, but guess what? Nobody seems to be able to find it. And it's all because it's all buried in spreadsheets or in mainframe systems, and you can get that data out into Microsoft Excel and start to make some sense out of it. So again, I'm really interested in money, right? And so Six Sigma will help you solve a lot of problems and help you find ways to save money. But a lot of people don't seem to know how to do that. And I've seen far too many Six Sigma programs shut down because people can't actually find ways to save the big money that's sitting out there. And if you're in any size of business, you should be probably guessing that you're losing about 25% of your total revenue expenses spent on fixing stuff that shouldn't be broken and throwing away stuff that you can't fix. That's where we're going. So if you have data that looks like this, and this is hospital data that I worked on about regions, the hospital, the admit date, and the amount of denied charges, well, that data could be worth $5 million a year, like it was to one of my clients. And if you have data that looks like this, so this is a manufacturing example about scrap, so we have production date and scrap description and scrap by weight, those things are also worth a lot of money, right? So we saved $1 million a year in that, right? So scrap is where you're throwing stuff away. You can't rework it. You can't fix it, if that makes any sense. So there's huge opportunities out there, and the bigger the business, the more opportunity there is. So Six Sigma is all about DMAIC and everything else, but I want you to think about that there's just 5 C's, right? So first we have to count the number of defects, mistakes, and errors that happen every day. Then we need to categorize them, so we need to summarize them. And I'm going to show you how to do that using pivot tables in Microsoft Excel. Then, once you've done that, then you can start to figure out what the root cause might be. And then we want to confirm that we made the improvement. And that's where a lot of people fall down. They make an improvement and they declare victory, and guess what? Nothing actually happened. So go about it. All right. So turning data into dollars, we start off with a raw data that's in some sort of Excel table, and these are line-by-line transaction kind of things. So in one hospital, Hospital 1, we had some denied charges. And so there's all this raw data out there about where the things are occurring. And I often go in and I work with hospitals and other companies, and I find people manually trying to summarize this data by hand. And I'm going, well, have you ever heard of pivot tables? And they say, well, what's a pivot table? So many years ago, probably 25 years ago, I was working in the phone company, and this is back Excel 5 and Windows. I was still running Macintosh because it was still Windows 3 of all things, right? So it was very primitive back then. But we had all this data coming out of the phone company, and so I had to figure out a way to summarize that wasn't such a pain. And so what I did was I started to fool around with pivot tables. And over the years, I've built some mental strategies about how do I take this data and put it in an order and let pivot tables summarize it for me so that I can then turn that into an improvement project that really tells a great story about what's going on. So we're going to take this raw data, and we're going to use pivot tables to summarize that raw data, and then we're going to use control charts and Pareto charts to tell a compelling story about what's going on and where should we focus our energies. One of the things that I find is a lot of Six Sigma things teach people that, we have to brainstorm, we're going to get a team together, and then we're going to brainstorm what we're going to work on. That's stupid, all right? I'm just going to say it right up front, because until you really know what you're looking for, you have no idea what you're looking for. And so what you want to do is use your data to figure out what problem needs to be solved, and then, and only then, will you know who should be on the team, right? If you just gather a team at random, they all want to solve different things. And there was an old Monty Python skit about the 100-yard dash for the directionally impaired. people lined up on the starting line, the gun goes off, and they all run off in different directions. Well, if you form a team before you know what problem you want to solve, you're going to be in trouble because they all want to go off in different directions. All right, so what we want to do is figure out what problem do we want to solve, then who should be on the team. All right, take pivot tables and take that raw data and turn it into some refined data. And then we're going to take that refined data and turn it into control charts and Pareto charts to help us narrow our focus to figure out what's really going on in here. All right, first step, we're going to figure out how to use pivot tables. And whenever I go out and teach classes to people on Lean and Six Sigma, I have a one-day Yellow Belt training, and I'll ask people for a show of hands. I'll say, how many of you know how to use pivot tables? And out of 25 people, 1 or 2 hands may go up. And they all say, well, and I ask them, and they say, well, I don't really know all that much about pivot tables. But I will tell you, every multi-million-dollar project I have ever worked on started with pivot tables. All the other stuff, maybe 100,000, 10,000 here or there, but the big money things all started with pivot tables. So that's what we want to do. We want to learn how to do that. So this is data mining. You've heard about data mining, but pivot tables will let you do that. And so pivot tables can count the occurrences of a keyword or phrase or number. So if you have a type of defect, it'll count that and summarize all that for you. It'll sum or count or average numbers, dollars, right? So in the case of denied claims, we're looking at dollars lost. It might be number of defects. It might be pounds of scrap. It might be the number of repeat phone calls to a call center where the customer has to call back and ask again and again to get the answer on something, right? So we can count the number of times those things happen and summarize them. And this is going to take your raw data that's out there in spreadsheets. It may be sitting in accounting systems. It might be in customer record management systems, CRM systems. It might be in SAP. It might be anywhere. I've worked with just all kinds of data from all kinds of places. You can always get that out of the big mainframe and put it into an Excel spreadsheet. And so when you have all these little defects that happen every day or year or week or whatever, then we can add that up and drill down into that amount of data and figure out where is the place we need to touch to really make big improvements. So when you do this, you have to set up your spreadsheet in a useful way. So there has to be a column. Every column has to have a heading. Now, people have the habit of putting blank columns in between various things so they can see them better. Don't do that, all right? Just expand the column, make it a little wider. Cells with no data should be left blank, all right? So if you have, Excel is going to count something, and if it's, R or any other crazy thing in it, just leave it blank. And then you want to find a way to make the data consistent, right? So if you're saying Colorado Springs versus Sea Springs versus whatever, right, you want to make a standard thing. I worked with one giant file of data, and they were talking about Medicare. And you can't imagine how many different ways people abbreviate Medicare. So it could be all 8 characters or MDCR or MDC, or it was crazy, right? So we had to get all of those to the same verbiage so that we could summarize them correctly. All right, so I've never found a spreadsheet or a bunch of data that didn't need some cleanup, so then actually summarize it all correctly. So you may need to do some global changes on certain things to get them to all look the same so that you can summarize them properly. This one, on the left side, there's 2 different regions, then there's different hospitals. We have admit dates, and then we have function codes, that's FC, what's the insurance company, and then what type of patient was it, and denied charges. We want about all of this. Make sense of this and find out where is what I call the Pareto pattern, right? I always talk, most people know Pareto's rule, that 20% of what you do causes 80% of your mistakes, waste, rework, and whatever. But I have found that it's much smaller than that. As little as 4% of what you do produces over half the mistakes, waste, rework, and error. That's one step out of every 25 is producing half of